Right. So I think we'll go ahead and get started. I think most people that registered are now here. So thanks everybody for joining our first fire break of 2024. Just want to remind folks that fire breaks are really a great way for folks within ANR to connect with each other and learn about all the great fire-related work we're doing across the state. For those who don't know me, my name is Katie Lowe, and I am the coordinator for the Fire Network. Today, we are joined by two of our fire advisors, Alison Deak, who is based out of Mariposa County, and Luca Carmignani, who is based out of South Coast Research and Extension Center. Alison is going to share with us some of the outcomes of a recent project she's collaborating on to document the formation, the accomplishments, and the challenges of establishing prescribed burn associations, or PBAs, across the nation. And Luca is going to share preliminary findings from an ongoing study evaluating the effects of irrigation on the flammability of native and ornamental plants commonly found in Southern California. So for those who need a little reminder, the format of this event is Alison and Luca. They'll each have 15 minutes to present on their work, and then we'll have some opportunity for group discussion and questions at the end. So yeah, and before we begin, a few basic Zoom rules. If you're able and comfortable doing so, please rename yourself, and then with your full name. And then during presentations, please keep yourselves muted. If you'd like to ask our speakers questions, you can either enter it into the chat and I can read it out loud, or you can raise your hand using the raise hand function. So with that, I will stop sharing and hand it over to Alison.
All right, thanks, Katie. Can everybody see my screen?
Yes.
All right. Thanks for the introduction. Like Katie said, I'm Alison Deak. I'm a fire advisor for Mariposa, Madera, and Fresno counties. And I'll be talking about some recent research I did with some colleagues, Lenya Quinn Davidson and Jeff Stackhouse at UC A&R, Jen Fawcett at North Carolina State University Extension, John Weir at Oklahoma State University Extension, and Chris Adlam at Oregon State University Extension. I want to give a bit of a caveat before we start. This is just a snapshot of what we've learned in our research, but we're really interested in what you gain from what I share here, and because we're still trying to untangle this story from the data that we collected. All right, so before we get started, I don't know how familiar all of you are with prescribed burn associations, so I'll define them. PBAs are just cooperative networks of local landowners, community members, community-based organizations, and agency partners working together to conduct prescribed burns. We conducted a survey in fall 2023. We compiled a list of PBA leaders for 133 known PBAs across the country. I'm sure there's more, but these are the only ones that we could find and nail down contact information for. A total of 74 PBA leaders completed the survey, so we had a response rate of 56%, which we were really happy with. Like Katie mentioned, the objectives for our survey were really threefold. One, to understand the formation, structure, goals, accomplishments, and challenges of PBAs. Two, to gather insight into the growing number and broad spectrum of PBAs. And three, to inform the development of future PBAs. And also, I think a big objective of all of us was to have a general accounting of what PBAs across the country are doing, why they're doing it, and how they're doing it, because this has been done regionally in places like the Great Plains, but it hasn't been done on a national scale. Looking at the geographic distribution and the age of the PBAs represented in our survey results, we feel like we were able to capture a good swath of PBAs across the country. You'll notice that we group PBAs by region as well for much of our analysis, as you see here. Looking at the number of PBAs established during each decade, we were able to see when and where PBAs have emerged over the last 3 decades. We have one PBA in our results that was established in the West in 1956, and this is a relic of the Range Improvement Association era in California. We have PBAs emerging in the Great Plains during the 1990s and 2000s. Between 2010 and 2020, PBAs began appearing in the Southeast, Northeast, and the West, and then there's just this absolute explosion of PBAs in the last 3 years throughout the country. And I'll mention, we did a special session at AFA about prescribed burn associations, And it filled the room with people that were interested in learning more about PBAs and starting PBAs in their own communities. So I think this really is a growing movement across the country. So we did ask respondents to share the number of acres burned and number of burns completed on average over the past 5 years. And our results show that they are accomplishing significant amounts of work, with some conducting an average of 50 burns a year and burning 10,000 acres, which I think is really impressive. This is really important in my mind because private landowners aren't generally viewed by agencies, policymakers, et cetera, as having a role to play in bringing fire back to the landscape. And I think there's a real opportunity for PBAs to begin to change this narrative and get a seat at the table, and we are beginning to see this in California, I think. The number of acres burned and number of burns annually did vary regionally. We saw the highest mean number of burns and acres burned was by PBAs in the Southeast, followed by the Great Plains, Northeast, and the West. And I think this could be from a number of factors. PBAs in the Great Plains and the Southeast tended to be much more established than PBAs in the West. It could be because of the fuel types PBAs are burning in, or how socially acceptable burning is within each region. We know that in the South and the Great Plains, prescribed burning is more of a culture, whereas here in the West, social acceptability is still a significant barrier for prescribed fire. Something else that I've kind of been thinking about is how funding and structure could also play a role. PBAs in the Great Plains and Northeast are much more dependent on donated time and equipment, as well as member fees, indicating that members might feel greater ownership over the work they're doing. PBAs in the West were the most reliant on grant funding, and our results show that they were more likely to have a paid position, especially from a partner or an umbrella organization. So this might be a stretch, but they may have additional grant deliverables or organizational priorities they need to meet beyond the PBA. And as highlighted by the Placer PBA, they're really only targeting low complexity burns due to capacity, training, and funding, as was written here. And from conversations with Cordy, their coordinator, they do burn often, but these are generally very small units because training is their #1 objective. In terms of why they're burning, this is for various reasons, and PBAs are adapting their objectives to the local ecology and needs. While in the West, prescribed fire for wildfire risk reduction and restoration of fire-adapted ecosystems is super sexy right now, I guess. Elsewhere across the country, PBAs are burning for many different reasons. Every PBA in the Northeast and Southeast reported wildlife habitat as their primary objective, while most PBAs in the Great Plains are burning for management of invasive species or woody plant encroachment and rangeland or forage enhancement, although these objectives were certainly not unique in their region. Interestingly, maximizing the number of acres burned and number of burns wasn't one of the most important actions that PBAs believe they should be doing. And only about 30% of those that did see this as their main objectives saw themselves as extremely or very successful at doing so, as you can see here. PBAs were more likely to view their role as broadening access and increasing public acceptance and understanding of prescribed fire, and most saw themselves as at least moderately successful at doing so. Also notable was that providing field-based training was one of the most selected answers to this question, and overall PBAs felt like they were very successful at doing this, or at least moderately successful at doing this. And going back to how PBAs are broadening access to prescribed fire, we asked PBA leaders about what their requirements for people to participate in a prescribed burn were. And our data showed that one of the ways that PBAs are broadening access to prescribed fire is by lowering the burden for participation. While nearly half surveyed said that they required proper PPE and clothing, only 18% required previous training and qualifications, and only 11% had age-based restrictions, which I think is kind of incredible. This leads me to argue that they're actively working to train the next generation of land stewards and prescribed fire practitioners, and in a way changing the fire culture so that anyone can participate in a prescribed burn. And I really love this quote here. I think it captures this well. Keep it simple, avoid unnecessary paperwork and MOUs. There are ample amounts of bureaucratic agencies in fire. Do not create another one with too much red tape and unnecessary requirements. And digging a little deeper into how they're providing these field-based trainings, we asked PBA leaders the average number of educational and training burns they were conducting annually, and less than a quarter reported not conducting any training. 78% reported all their burns to be considered training events, and over half provided opportunities for community members to be involved in burns through learn and burn events and demonstration burns, as you can see here. And again, another PBA wrote that their goal is training and outreach. They're unable to help all of the people in the country that need or want it, but we hope to enable others to do burns on their own, so we don't need to be involved in all private land burning in the county. Also interesting was to see how the needs of PBAs changed through time. While motivated landowners and strong leadership were important for both establishing and sustaining PBAs, support from agencies and other organizations, staff, and connecting with other successful PBAs and practitioners were viewed as less critical after PBAs were initially established. We were also interested, somewhat selfishly, I'll say, in how important partnership from different organizations were for PBAs. So we asked specifically about how important partnerships with Cooperative Extension was, and only a little over a quarter considered this unimportant, which was, I think, higher than we expected. And this quote from the leader of the Southern Blue Ridge PBA in North Carolina gives some insight into why this support is important, writing that support from our partner agencies has been critical to our success, while funding and resources and steering the PBA during leadership transition. So like I said, this is just a small snapshot of our results, but some of the key takeaways that we've drawn from this are PBAs are a bottom-up grassroots approach to land stewardship. They're showing alternative models of fire management are possible. They're broadening access to the use of prescribed burning and training the next generation. And they're providing exciting research and extension opportunities. And as we argued in our presentation at the Association for Fire Ecology, is that they're offering opportunities to reach new clientele for us in Cooperative Extension and open up new conversations about the role of landowners in fire. So next steps for us, we're currently writing a manuscript to publish in the International Journal of Wildland Fire. We are going to put together some fact sheets targeting PBA leaders, practitioners, and policymakers, and these will be based on different subsets of our data that might be interesting to them. We'll be doing some qualitative interviews to try to dig more into the why and how of what we found, and we're planning on doing some peer learning summits across the country to share this and learn from people on the ground. All right, that's all I have. I'm happy to answer any questions or hear thoughts that anybody might have.
Thank you, Allison. Does anyone have any questions for Allison? If not, maybe we can transition to Luca and maybe people will have more time to think of the questions to ask you at the end. All right. Well, thanks, Allison. Yeah, we'll hold off maybe to a question or for questions until the end. So, Luca, do you want to start sharing your screen?
Yes. 1 second. Oh, where did Zoom go? So, can you see the
Yeah.
slideshow? Oh, I don't know what it did. Can you see the slideshow?
Yes.
Okay, awesome. Hello, everybody, and thank you for joining us for this fire break today. I'm Luca Carmignani, and today I wanted to talk a little bit about the research on plants flammability that I've been doing at the South Coast Research and Extension Center. So why do we talk about plants flammability? I'm sure most of you already are familiar with this, but in general, intuitively, we don't want something that is very flammable close to homes and communities. And so definitely flammability is a very important aspect to assess the risk for structures and neighborhoods. And also, it's a very important factor into designing landscapes that are more fire resilient. And the aspect of vegetation flammability is also very important to provide residents and fire agencies with sort of like guidelines and recommendations that can be used by homeowners and residents. And another very important aspect is that when we're looking at fire spreading in the wildland-urban interface, or areas where we have a mix of native and non-native vegetation and structures, the fire behavior models are not extremely accurate in terms of predicting the spread of the fire and the intensity. So these kind of data can provide more input to this model to create more accurate predictions. And you're probably have crossed paths at some point with list of plants, and are they good or not? And there's like a variety of this list, and some of them are based on some scientific testing, some other not. But in general, they have some good aspects, and definitely are very good to provide some guidelines for residents and other people interested in creating landscaping. And also, it's nice that this list can be combined, for example, with drought-tolerant plants list or pollinator plants. And so having sort of a scale that tells us how flammable is a plant can be a good thing for educational and outreach purposes. On the other hand, these plants can kind of give a false sense of safety when in conditions that might not be that safe. And also, another important aspect is that these plant lists usually do not give information about the behavior of the fire behavior of the plant. So for example, once it's ignited, how it's going to burn, if it's going to burn completely or not, and so on. And most of these lists are based on qualitative observations, for example, from post-fire examinations and so on, and rarely are based on scientific testing. And in these situations, for example, the testing that have been used in the past usually come from methodologies that have been used for example, for material flammability, which may not necessarily correlate to the flammability of living plants. So what is really plants flammability? Because we talk a lot about it, but there's a lot of different definitions. And just to narrow down some of the flammability components that I will be talking about, from the previous research, there's four main components, and one of them is the ease of ignition. So how the plant will ignite, how much time will it need, and how we ignite it. For example, it could be a flame exposure, could be ember deposition, and so on. And another important aspect is how fast the plant will burn once it's ignited, and also how long will that burn for. And if we look more at the biomass of the plant, and another important aspect is, will the plant burn completely, or maybe will just burn partially? And as I mentioned before, there's not really a standard methodology to address these answers. So there are some studies in the literature that have looked at some of these aspects, but it's hard to look at all of them at the same time. And of course, there's a lot of factors that determine the flammability of a plant. And besides the species, definitely the maintenance of the plant is very important, the amount of that material that accumulates during its life, and the seasonality, on the landscape and irrigation, more in an urban environment, definitely affects the flammability of the plant because it relates to the water content. And also the size of the plant and maturity is an important factor too. Because for example, if we try to burn a small twig, it might give us different results compared to like a full tree crown, for example. So here I wanted to show some of the preliminary results that we gathered last year in collaboration with UC Irvine, Professor Banerjee, and Dr. Pedersen. And in this study, we leveraged another study that was ongoing at the South Coast Rec, which is the UC Landscape Plant Irrigation Trials. And this study looks at the drought tolerance of plants, and they use 3 different irrigation frequencies. They're basically less water than the plants actually would need to see basically the water deficiency that is allowable to allow these plants still to thrive. So there here on the right, you can see the plots at the rec, and they're basically this is basically a great situation to have a control study with plants that are exposed to the same conditions in the field, but at 3 different irrigation frequencies. And also, as you see from the figure here, these 2 plots are the one that we consider in this study, and the same plants that we consider that were grew full sun exposure, but also grown at 50% shade. So we had 2 variables. One was the irrigation, and the other one was the sun exposure. And we had 43 plants, which basically corresponded to about 6 to 8 repetition for each condition. And again, one condition was irrigation frequency as well as sun exposure. And we wanted to have realistic experiments, so we tried to run the test in an open field situation and full scale, because we wanted to look at the effect of the size of the plant as well. And for this test, we ignited the plants manually with a propane torch at the bottom of the plant on one side, and we will see more of this in a video. And the idea was to have these experiments as realistic as possible, and so basically representing the field conditions. So I mentioned we had 2-year-old plants that were established at South Coast Rec. So ideally, we wanted to burn them on site, but that was not possible due to delays in permits and other issues for other safety issues. So we removed them from the field, and we stored them in a greenhouse for a few days, because at that time there was a storm coming. So we didn't want to have the rain affecting the irrigation results. And then we measured the moisture content, the initial mass of the plants, and then we brought them back into the field and we burned them within 4 days, burning about 9 to 12 plants a day. And this is just a picture of the experimental setup. It's pretty straightforward. We had the plant burning on a gravel surface, and we had 2 heat flux sensors that measured the total heat flux. So that means both radiative heating and also convective heating that will come with the airflow. And we had a couple of cameras recording the experiments, and we also had a sonic anemometer to measure the basically flow field around the plant, because of course the buoyant flame column and the smoke column could have affected the wind speed around it. And this is an example of how an experiment would look like. I ignited the plant here at the bottom, and we can see here on the x-axis there is time, and on the y-axis the total heat flux that was measured by the 2 sensors. We can see that during the ignition the heat flux goes up pretty quickly, and here we have a little bit of a variation between the 2 sensors, and that's because they were placed at a 90 degrees angle. So sometimes one of them will get hit by the smoke plume, and in that case the convective heating would increase, while the other one would catch only the radiating heating. So that's the reason why we put them at 90 degrees, because the smoke plume would sometimes change direction. So in this way, one sensor was always free from the smoke. And here you can see that the heat flux increased and then eventually starts decreasing. So we selected the peak heat flux values to sort of characterize the plants and the effect of the irrigation and sun exposure on the total heat flux. And in this graph here, we just, again, represented just that peak value for the plants that were exposed to 100% sunlight. And on the x-axis here, there are the days that the plants spent in the greenhouse. So of course, the more time they spend in the greenhouse, the drier they got. So you can see that overall there is an increasing trend of the total heat flux that was generated by the plants, and the shade, the shade of the color represents the irrigation frequency. So the darker colors darker symbols were the ones that were irrigated the most, and the lighter ones the least. And we didn't see a big trend in terms of irrigation. And if we add the plants that were a 50% shade, we get again this increasing trend with the days the plants spent the greenhouse. But again, we didn't see a very clear trend for the irrigation frequency. And the things got a little bit better when we tried to plot the total heat flux versus moisture content of the plant. There is definitely some scattering of the data, but overall, intuitively, it's confirmed that the higher the water content of the plant and the lower is the total heat flux that is generated by the burn. And just to summarize this preliminary study, we didn't see a big impact of irrigation. However, there were a few storm events that happened before the experiments, so that might have kind of leveled out the difference in irrigation that we wanted to look at. And interestingly, the 50% shade plants showed higher values of heat flux that was generated. And we didn't expect that because the plants that were grown in the sunlight, full sunlight, had a little bit more dead material. So that was interesting. And definitely the time that the plants spent in the greenhouse had a big effect. And again, we didn't measure the mass during the experiments, so the total heat flux might not represent for example, the size of the plant itself. But this study was very, very useful to plan the new step in the research. So this is a new research facility that I've been working on for the past year. And basically, to avoid some of the issues that we had before, we wanted to build a metal structure, sort of a frame that would enclose the plant to be tested. And for ignition, I wanted to have something more reliable and more consistent. So I created a propane burner for the ignition phase. And also we wanted to increase the measurement of the test. And so we introduced a mass loss measurement system, which basically consists in a scale. And then we're going to have more heat flux sensors, and some of them will be able to distinguish between convective heating and radiative heating. And also we'll use infrared cameras to try to map the temperature for example, at the base of the plants. And I just wanted to conclude with a couple of videos showing where we're at. So this is the structure in the field. I apologize, I still have to improve my drone abilities. But yeah, this is an aerial view. These are the plants that will be selected for the new study. So these plants over here will be ready at the end of the actually already ready to be burned. I haven't gotten a chance yet. And here there are more plants that will be ready in the next few years. And here you can see the structure is 15 by 15 feet wide and 12 feet tall. And so I put a metal mesh on top and on the top sides. And to improve safety, I'm gonna basically cover some of the sides completely with a mesh screen. And here you can see there is the propane burner for the ignition. And here where there is this metal bucket, that's where the plant is gonna be. And this is how the propane igniter is looking like so far. And there's the propane that is fed by just a regular barbecue tank. And I have these spark igniters that are placed here. So once I start the flow of propane, I just ignite it, and then you get this U shape. And the idea was to simulate the flame approaching the plant. So that's why we got this U shape, because we can just move it close to the plant and simulate the flame coming from one side. And yeah, and so here the plant will be here on top of the scale in a metal container. So this is all I have.
Thank you, Luca. I see we have a question from Steve in the chat. Luca, would you review again the relationship between irrigation level and amount of dead material in the plant?
Yes, that's something that ideally I would like to map the biomass of the plant, like green versus that material before the testing. And if I get funded and I'm able to like hire an assistant, that would be awesome. And for the immediate for the experiments that I'm planning in March, I'm not gonna measure that biomass, but it would be definitely good to do it. I don't know if I answer your question, Steve.
I thought you had done some of that in your work. I thought you talked about both of them during your presentation just now. Did I miss it then? You didn't really
Oh,
do
well,
anything with regard to dead?
we measured the initial mass of the plants, but unfortunately we didn't really measure the dead versus green. It just like from a visual observation, the plants that were grown in 50% shade were much greener and had a lot less dead biomass, but we didn't quantify it.
Yeah, so just a qualitative observation so far.
Yeah.
Thanks very much.
Luca, Yana asks, are you studying woody plants too?
So the structure that I'm building should allow me to burn plants for now up to like 3 feet tall, but I would like to be able to make it safe like up to 5 feet tall. So that would allow me to burn like, more woody shrubs. And ideally, once you have the plants, that they don't have to be necessarily the ones from the South Coast Rec, but if you have like significant plants that you want to be testing, you can just bring them there and yeah, test woody material as well.
Yana asked a follow-up, is the shade changing the architecture of the plant?
From a visual observation, only the size and again the green aspect of it were affected, but the shape itself was pretty similar. At the same time, these were like grass-like plants, so it'll be interesting to see if with more shrubs there is a difference in growth, shade versus sunlight, but for this kind there wasn't any difference.
Cool. I guess we'll transition to the general Q&A session with Alison and Luca. So if folks have questions for either of our speakers, feel free to unmute yourself. It's a small enough group, so feel free to unmute yourself and ask your question, or you can type it in the chat.
I have a question for Alison.
Mhm.
So I've been wondering about this, and maybe you've done some work or can talk about it. And I think that is from a local community level, there's always this question as to, with regard to the cost of prescribed burn and the effectiveness of it versus the other kinds of strategies that could be used for fuels treatments like goats or manual removal. I mean, have you or your colleagues, come up with like an easy table that a community could use to decide what approach to use that would be best for them, regarding these various strategies for fuels treatments?
So you're asking about cost effectiveness and
No, the cost and the effectiveness of the, cost and effectiveness. So
yeah, so I think it really depends on your objectives. As if you're going for fuels reduction, I mean, a lot of times you are going to have to do some kind of thinning or other treatment before you're going to be able to go out and burn if you're in a forested or a woodland environment, like I am in the Sierra foothills. And so if you're going out and doing that, I mean, you are going to do that thinning first, but in terms of maintenance, I think it's a lot more effective and cost effective to be able to go out and do a burn to maintain those treatments in the first place than to continue to do the manual labor to maintain that property.
So how long might a burn last? I mean, if you burn this year, are you going to be burning next year too? I mean, on the same plot of land?
I mean, it depends on the conditions and the ecosystem. So if you're doing a grassland environment, you could be burning up to every year. But in a woodland environment or a forested environment, it depends on how much fuels you have to carry. Yeah, I mean, I think as far as cost effectiveness goes, prescribed fire is generally more cost effective because it takes much less time to go out and do it. Goat grazing in my area can be up to $2,000 an acre. And for the PBA to go out and do it, it costs fuel and maybe some of my salary, and that's it. So I mean, it's really dependent, I would say, though, on what you're doing and who you're doing it with. If you're hiring a contractor versus going out by yourself,
Right.
there's so many
Okay.
variables.
Yeah, thanks very much. And Katie, thanks for putting that in the chat. Appreciate that. And thanks, Allison. Nice talk. Same to you, Luca. Nice job.
And yeah, for those who are just opening the chat, the Fire Network, we have like a brief synopsis of comparing different treatments, both in terms of cost and effectiveness and among vegetation types on our website. And I pasted that link in the chat. I had a question for Allison, actually. You mentioned in your presentation that there are some PBAs, like the plaster PBA, which is in my area. They focus more on low complexity burns just because of local interest and ability. But I was wondering if there are some common challenges faced by PBAs across the nation who want to break into that moderate complexity burning, because that is something that the placer PBA is exploring right now, and we just don't know how to navigate that.
Yeah, that's a good question. I think there's a number of challenges, but I think the big one probably is just having the skill sets, and having enough people on the burns with those skill sets. In California, I can speak for California. I mean, for us to go out and do these more complex burns, we have so much fuel on the landscape that it's incredibly challenging to just be able to just go do you need so much work to even put fire on the ground here. So to be able to do that on a large scale is really difficult. And then a lot of these PBAs are working with people that might not have a lot of experience with prescribed fire or any fire experience at all. I know in my area, most people don't have very much fire experience. And you want to have people that, like if you go to a Trex event and they're doing these more complex burns, you have people that are RXV1s and you have people that have spent decades in fires, you have multiple engines there. So there's a lot of capacity limitations, I would say. And somewhere like the Great Plains where you're burning, a very their fuel type is you're in a grass system, it's a lot easier to get a lot of acres than it is here, and we did ask specifically about what challenges PBAs had faced, and some that came up that a lot of people selected was risk liability concerns, too few burn windows. They need help prepping units, and people just want to go out and burn. They don't. We see that with our PBA. People want to go out and burn, but they don't want to actually do the work to actually get the property ready to burn. Not enough active participation, and lack of funding or equipment. So I mean, these challenges are pretty consistent across all PBAs across the country.
Thank you. Brent asks if you have, Allison, if you have connected with the Pennsylvania Prescribed Fire Council.
I haven't, no, but I was at the Association of Fire Ecology. I was talking to somebody in extension up there that's very interested in starting a PBA. So we could see our first ones there soon, hopefully.
Yeah, and they also, the extension there has the Pennsylvania Woodland Association, I'm sorry, Pennsylvania Woodland Owners Associations, plural. There's a bunch of them. And So they connect with them, provide recommendations, training, and then they also work with the prescribed fire council to make recommendations, teach classes to landowners and so forth.
Do you work with them a lot?
I was director at Penn State prior to coming here,
Okay.
so I'm happy to make connections if you don't have them.
Yeah, that'd be great. I'd be happy to share what we've learned in the study. I mean, one of the big goals of ours was to, give some kind of guidance. Not all PBAs look the same, but this is how a lot of PBAs are structuring or trying to, work their way through and give people ideas about how to at least get started. Because I know it seems really overwhelming when you're trying to start from scratch. So I'd be happy to connect with them and share what we've learned.
Okay, I think Cleo has the last question for today. So for Allison, what are some of the complexities you're hoping to dig into with the follow-up interviews, and who are you planning on targeting for those interviews?
A good question. So I think we'll probably dig through the data. We only have 74 responses, so it's kind of easy to pick and choose who we want to talk to. I think we want to get a good regional variation, people from across the country, different stages of development. PBAs have been around for a long time versus PBAs that haven't been around for so long. I think we're really interested in learning how they're overcoming barriers, learning more about how they're structured and how that works. I'm really personally interested in the statewide PBA model. Places like Texas, places in the Great Plains have statewide PBAs that provide a lot of support for all the smaller PBAs across the state. And I think there's a lot of benefits to that. So I'm curious about what those benefits are and what are the limitations of that. And then we did ask a question specifically about secession of PBA. So what happens if key leaders of your PBA were to leave? What would happen? And so a lot of PBAs said they didn't know what would happen or it would fall apart without those key leaders. So what does that look like? Why are they so dependent on a single person for sustaining the PBA long term? And then, what are the solutions? I think for a while I was meeting with other PBA leaders across the Sierra, and we were all struggling with a lot of the same things. So if we can come up with really good advice for other PBAs that are just getting started or still figuring it out, even though they're decades into it, I think that would really be helpful for PBAs across the country.
Great. Thank you so much, Allison and Luca, for your awesome presentations for today. And thank you everyone for joining us for our first fire break of the year. We will be sending out information to all of you in the coming weeks about our March fire break, which is to be determined. So stay tuned for that. And if you are curious, all of our fire breaks in the past are available on our web or on our YouTube channel, which I will send out in a follow-up email to you all. So feel free to peruse those and share those with your colleagues. So thank you so much for joining, everybody. Have a good one.
Thank you.
Thank you. Bye.